So, welcome students. So, welcome to NEET World. So, yesterday we have seen the questions in EAPCET, like we have solved some questions. So, we will continue with the remaining questions today. Okay. Up to which question we have stopped? The question number, yes, this one we completed. Yeah, we completed up to the 6th question, right? We will go for the 7th question now. Okay. I guess it's visible, right? Let me check it, okay? Yes. Yeah, fine. Okay. So, the blade of a windmill generating electrical energy sweeps out an area of 20 meter square. Let me take a marker here. Yes. So, 20 meter square, the given area. If the efficiency of the windmill, so efficiency is 25% they have given. So, wind speed is 36 km per hour. Then the electrical power generated is, so they are asking about the what is the electrical power generated. See, when I take a windmill, okay, I will draw something, okay. Let me take a windmill. The wings will not rotate automatically, like some air should come, no, like the wind should blow, then only the blades will rotate, right? So, what will happen first? Wind is there. So, after a wind blows, the blade rotates, then the power generate, right? The power will generate. So, what we need to find here? The power we need to find, right? So, first of all I need to find the power of the wind first. So, how much power the wind has been given to the blade, then how much power it has been generated, like the efficiency is 25% they have said. Let me calculate. What is the power formula we know? Like power is equals to work done by time. Okay, we know that we can take energy by time also. What is the energy? Like we have, like we can take here, it is kinetic energy, no, like it is, the speed is given as 36 km per hour. So, I will take half mv square by t. And one more thing, they have given that the density of the air, that is 1.2 kg per meter cube. So, this is density and this is velocity and this is efficiency, that is eta, no, okay. What about this area? This is A, okay. Sir, area given, efficiency given, density given and velocity given. What about the mass and time, sir? They have not given, right? How we can take this? See, let me explain you. We know that density is equals to mass by volume, right? Mass by volume. So, what is mass here from this? Mass is nothing but density into volume. Okay, sir, you have got mass, that is density into volume. What about the volume? They have given only area, right? See, we know that volume is nothing but length into length into length, that is L cube, right? What about area? It is length into length, that is L square, no, or A square, we will take it, okay. See, I will write here, I will write L into L, okay. For your understanding, I have written length into length into length. So, I can write this as rho into L is area, right? I will write area as it is, then length, okay. Now, I will take the formula and substitute here of m, that's sorry, m is we have taken as rho a L, no. So, rho a L, I will take the t here, L by t, okay, into v square. Usually, like velocity, how we will measure? A displacement by time, right? How the displacement has been calculated in the units, that is length. Time is seconds. So like meter, no, like meter per second, no. So let me take this as meter per second. Then what is the thing? That is velocity, right? So half rho a v cube. Hope you understood the formula, like how we got the formula, half rho a v cube, right? Now we can substitute the things. I will take here. So power of the wind. First we are finding power of the wind, that is half into, what is the density? It is 1.2, right, into 1.2 into area is 20 meter square, and the velocity is, okay, it is given in 36 kilometer per hour, no, change it to meter per second. 36 into meter per second means I need to multiply by 5 by 18. So 1 sir, it is 2 sir. So answer will be this 10. This is the velocity, right? This is about the velocity. So multiply 10 cube. Okay. So this is 1 and this is 1. I mean 10 times will go, no? So 1.2 into 10 is 12. So 12 into 10 power 3, which is nothing but 12,000. Right? 12,000. This is the power of the wind. So this wind has the blade, and the blade rotates and generate the power. Okay. Now let me take up space here. So power of the wind is equals to how much efficiency? 25% they have said. So 25 by 100, or I will take the formula here, that is eta into power of the power generated. We will take sorry, this is, yeah, power of the electrical or power generated will take, electrical generated is equals to eta into power of the wind, right? This much power has been applied to the electrical blade. The efficiency is 25%. Okay, 25 by 100 into what is the power of the wind is given, that is 12,000, right? So cancel it, and if you multiply, you will get the answer as 3 kilowatt, that is 3000 watt, or I can write it as 3 kilowatt. Hope you understood the question, right? We'll go for the next question. Yeah. Okay. Now yes, a uniform meter scale of mass 700 gram. Okay, meter scale, it is 1 meter scale has been there, that is given. How much mass is there? Mass is equals to 700 gram. Okay, then what are the things they have given? Suspended horizontally. Okay, suspended horizontally using two strings tied at 20 centimeter and 70 centimeter. See here, 20 centimeter and 70 centimeter, like they are suspended at something like 20 centimeter and then suspended at another string, that is 70 centimeter. So this is 100 centimeter, no? So this 100 centimeter scale. Then the tension in the string at 70 centimeter, I need to find what is the tension. Okay, now the gravity is given. Okay, let me take the center. What is the center point of the scale here? 50 centimeter. Okay, now what is the weight of the scale? Weight of the scale, that is W is equals to mg, right? Mg. That's why they have given gravity, that is 10 meter per second square. We need to use. So mass is 700 gram. So convert it into kg. 700 divided by 1000, right? 2020 and 0.7 kg, right? So 0.7 into gravity is 10. So 7 Newton. So keep this as it is. Okay, keep as it is now. Now I need to find the tension. Take any one point and find the torque due to the, like if I take this point, no, find the torque for this point and this point. Okay, like I will take the reference point as this one. Now if I see, no, from 20 centimeter to 50 centimeter, that equilibrium point, like 50 centimeter is said to be equilibrium point, no, the center point. So how much distance is this? 30 centimeter, right? What about the distance from this point to this point? Like from 50 to 20 I have taken, again 70 to 20 I have taken, this is the reference point now. Now 70 to 20, what is the difference? 50 centimeter, right? So this one I can convert it into meter, right? 0.3 meter, right? This one 0.5 meter. Now listen carefully. Torque in the sense force into the distance, right? What is the force here? Like let me take from center point we have taken, no, that is 7 Newton. Okay, the distance is 0.3 is equals to tension 2. Like this is the tension 1 and this is the tension 2, right? That's why I have taken tension 2, and the distance is 0.5. So 7 into 0.3 divided by 0.5, I will get tension 2. 7 into 3 by 5, which is nothing but 21 by 5. So approximately I will get like we will get 4.2 as the answer. 4.2 Newton. Okay. Yes. Yeah, we will go for the next question. Okay. Yes. So uniform circular disc of mass is given as 40 by pi kg. Okay, I'll write. Is rotating about an axis passing through its center and perpendicular to its plane. So note this point, why they have given us, like I need to take the moment of inertia of the circular disc, right? Plane with angular speed. So omega is equals to 150 revolution per minute. I need to change it for radians per second. So 150 into 2 pi by 60. Okay, 0 0 1, this is thrice, so this is 5. So 5 pi is my angular speed, okay, in radians per second. I have changed revolution per minute to radians per second. Now if the angular momentum of a disc, angular momentum, that is L is equals to, they have given 6.25, then its radius, okay, what is the formula for angular momentum? I omega, right? I omega. So angular momentum is equals to I omega. So what is the formula for like I, what is the meaning of I? Moment of inertia, right? Moment of inertia of a circular disc. So passing through its center and perpendicular to its plane, that is of mr square into omega. Okay, this is about the formula. Now about the calculation part. So 6.25 is the given, what is the given? Momentum, right? Is equals to half into, mass is given as 40 by pi. 40 by pi into r square. I don't know, I need to find the value of r. Omega is 5 pi into 5 pi. So pi will get cancelled, and this 1 and this is 20 times, right? Right. So 6.25, if I take 20 into 5, that is 100, no? Divide by 100 is equals to r square. R square. So I'll erase this point. Now, so r square is equals to 625 divided by, if I take this point out, no, it will be 10,000, right? If I take the root over 625 divided by 10 power, 10,000, which is nothing but 25 into 25, 625 divided by 100, which is nothing but 0.25 is the answer. So in centimeter they have given 25 centimeter, in meter it is 0.25. Hope you got the clarity of this question. No? Okay, we'll go for the next question. Yes. Yes. The question says the displacement of a body executing simple harmonic motion y is equals to 8 cos of pi t, okay, where t is in time in seconds. Okay, the displacement of a body in time interval between 1.5 seconds to 2.5 seconds they are asking, no? So this, like they have given the equation y is equals to 8 cos of pi t. So at 1.5, what is the value of y? 8 cos of pi into, that is 1.5. I can write it as 15 by 10, right? 15 by 10, no, which is nothing but 8 cos, this is 2 times, this is 3 times, no, 3 pi by 2. Next, y at 2.5, no, 2.5 seconds, which is nothing but 8 cos of pi into 25 by 10, which is nothing but 5 by 2. So 8 cos 5 pi by 2. So give me the give me answer for the cos 3 pi by 2 and cos 5 pi by 2. Give answer in the comment boxes, guys, who are watching. Okay, so it is 0 for both. Cos 3 pi by 2, cos 5 pi by 2 is 0 only. Okay, so 8 into 0, this is also 8 into 0, which is nothing but 0, right? So what they are asking, displacement of a body in time interval. So delta y is equals to y 2.5 minus y at 1.5, which is nothing but 0 minus 0 is 0. So what is the answer? Yeah, 0 is the answer. Okay. Next we will go for the question number 91. Yes. Okay. So weight of a body at a height of 3 r from the surface of the earth is 90 Newton, where r is the radius of the earth. The weight of a same body at height of r from the surface of the earth. Okay, what is the formula we know? Like weight, if earth, like height varies, no, w h is equals to weight of the earth re by r plus h. This is the formula we know. What is the first condition they have given? Like at height 3 re, the weight is 90 Newton. I will write it. So 90 Newton is equals to W naught re by re plus 3 re. This is the first condition they have given. Equation number 1. Now if I talk about the second thing, height is same as radius only. So WH is equals to W naught into RE by RE plus RE, right? So WH will be, this is something around 3E, this is same RE, 3RE RE, okay, is equals to W naught RE minus, RE by 2RE. R by 2R. So RR will get cancelled. Here if I solve this one, no, I'll get W naught. So R by 4R, I'll get 1 by 4. 1 by 4. This is equation 1, no, and this will be my equation 2. So if I divide the both equation, no, I can equate them like I'll get cancelled out W naught, right, and I can find the W at height RE, like the weight of the earth, like weight of the body, right, weight of the body. So W H 3RE 3RL, right, divide by the like weight at height R equals to, this is W naught and W naught will get cancelled, 1 by 4 divided by 1 by 2, 1 by 4 divided by 1 by 2, right. So by equating this equation I can find this one, I can write it as 90, the given thing, the weight is given as 90, right. So I can find easily the weight of the body at height H is equals to R. So answer will be 360. Okay, we'll go for the next question, guys. 92nd question. Okay, I'll give a hint for this question, try it out. So when a metal wire of area of cross section, so the given area of cross section is 1.5 into 10 power minus 6 meter square, is subjected to a tension of 45 Newton. So tension is given as 45 Newton. Okay, the decrease in area of cross section, like change in area, that is 3 into 10 power minus 10 meter square. If the Poisson ratio of the material of a wire is, this is the Poisson ratio, right? So this is 0.4. The Young's modulus of a material of a wire, I need to find the Young's modulus, right, Young's modulus. So first use the formula Poisson's ratio, and then I need to use the formula Young's modulus. So I explained the question, try it out, guys, give the answer for this question now. Okay, you give the answer in the comment boxes. Okay, so we'll go for the next question. Give the answer, guys, for this question, question number 92. Okay, next question. Yes, so a tank is filled with the water to a height of 80 centimeter from its bottom. Okay, let me take the tank. Okay, they have not said about the tank height, they have said about the water height, which is filled from the bottom something around 80 centimeter, right. A speed of efflux of water through a hole on a side of a wall of the tank near its bottom, somewhere they made a hole here. Okay, so the water will flow like this, no, come out like this. So I need to find what is the speed of that. So speed is nothing but V is equals to root over 2GH, the direct formula is there, no. So now I need to change it to meter, 0.8, root over 2 into 10 into 0.8, which is nothing but, this is, yes, 16. So 4 meter per second is the answer. Yeah, 4 meter per second is the answer, guys. Yes, it's 4 meter per second. Yeah, you have done correct. Yeah, man, you have. It's correct only. Fine, fine. Okay, we'll go for the next question. No issues. Okay. So energy required to increase the radius of a soap bubble. I need to find what is the energy to increase the radius of a soap bubble from 3 centimeter to 4 centimeter. Okay. The surface tension has been given. I need to find what is the energy. So simple formula. W is equals to 8 pi T into R2 square minus R1 square. That's it. The direct formula is there for this question. So I can substitute the values, no? 8 into 22 by 7 into, what is the tension given here? 3 into 10 power minus 2, right? So 3 into 10 power minus 2. 10 power minus 2 into. So it is given in centimeters. I need to change it into meters. So 0.04 square minus 0.03 square. So 8 into 3.14 into 3 into 10 power minus 2. This one 0.0, I will write it as in your conditions, 4 divided by 100 by minus 3 divided by 100. The square, whole square guys, don't forget, it's a whole square. Next, this is 8 is 24 into 3.14 into 10 power minus 2. I will keep this 3.14, at last we can multiply it. So this is 16 divided by 10,000 minus 3, like 9 divided by 10,000. Right. Now the final calculation. Give the answer for this question, guys, after doing the calculations. Yes. Yes guys, it's 528 into 10 power minus 6. Yeah, 528 into 10 power minus 6. What is the answer? So option A. Option A is the answer. We'll go for the next question. What is the time? What is around 12:58. Okay, I'll give a hint for this question. You solve it and give the answer, and we'll solve in the next class this one. A metal plate of a mass 50 gram is heated. Okay, metal plate. I'll write first what are the given terms here. What is the mass? 50 gram. Okay, 50 gram. Heated to a temperature. So the temperature T1 I will take. This is M1. T1 200 degree Celsius. Then it's immersed in a 150 gram water. So M2, mass of the water, that is 150 gram. So water temperature T2 is equals to 20 degree Celsius. If the temperature of the water is 50 degree Celsius, okay, at equilibrium. So its equilibrium temperature, guys, T equilibrium is equals to 50 degree Celsius. Then the specific heat capacity of the metal. So specific heat capacity of water has been given. Okay, that is 4200 joule per kg Kelvin has been given. I need to find the specific heat capacity of the metal. What is the formula we know? Like MC delta T, no? This is the formula for the heat. So heat loss is equal to heat gain. That condition we know. I can write M1 C1, this is delta T, no? Delta T is equals to, this is M2 C2 delta T. M2 C2 delta T. This is the condition we know, right? How I can write this one? M1 C1 T1 minus T is equals to M2 C2 T2 minus, sorry, T minus T2. Okay, I have given the equation, only the substitution part is left out and calculation is left out. So do the calculation and give in the comment boxes, we'll check it out. I'll solve the question in the next class. Okay. Thank you guys.